Welcome to The Explainer. So have you ever really wondered how a machine actually learns? It's not just one single thing. Today, we're going to break down the three fundamental ways AI learns. And these methods are behind everything from your email spam filter to the most advanced self-driving cars.
Right. Let's start there. When we use that word learns, what are we really saying? Is the machine just, memorizing a bunch of stuff? Or is there something deeper, something more interesting going on? Well, let's dive in.
What's so cool about this is that at its heart, machine learning mimics the way we humans learn. It really boils down to three main styles, and they're gonna feel pretty familiar. Learning with a teacher, figuring things out on your own, and good old-fashioned trial and error.
Okay, so first up, we've got the one that's probably the most intuitive, supervised learning. I want you to imagine you're back in school, studying for a huge test, but this time you've been given a perfect study guide with every single question and, crucially, every single correct answer.
So what that means in practice is that we're training an AI on a massive data set where every piece of information is already labeled with the right answer. The whole point is for the machine to figure out the pattern that connects the input to the correct output. The flashcard analogy is perfect for this. The machine gets shown the front of the card, the question, and the back of the card, the answer. And it does this millions, maybe even billions of times until it gets so good that you can show it a brand new card it's never seen before and it can predict the answer.
And here are some real-world examples of those flashcards. The model gets fed the text of an email and it's labeled spam. It sees an image of a dog and it's labeled dog. It analyzes all the features of a house, and it's paired with its final selling price. It just keeps going, over and over again, until it learns the invisible rules that connect the two columns.
Now, this whole approach is really good for two main kinds of jobs. The first is classification, which is basically sorting things into buckets. Is this email spam or not spam? Is this a picture of a cat or a dog? The second is regression, and that's all about predicting a specific number, like what's the price of this house going to be? And look, this isn't just theory. This is the technology running in the background of your life every single day. It's the engine behind your spam filter. It's what recognizes your friends' faces in photos. And it's even helping doctors make more accurate medical diagnoses. It's everywhere.
Okay, so that was learning with a teacher. But what happens if you take the teacher and the answer key completely out of the equation? Well, then you get our second style, unsupervised learning. Now the machine is on its own.
With this one, we give the machine a giant, messy pile of data with no labels, no answers, no instructions, and we basically just say, go figure it out. The goal here isn't to predict a correct answer, because we don't have one. The goal is to find interesting, hidden patterns inside the data itself.
I love this analogy. Imagine you're just dropped into the middle of a city you've never been to. Nobody has a label on their forehead. But just by watching how people talk, what they wear, where they hang out, you'd start to see patterns. You'd start to figure out the different social groups and communities. That's exactly what the machine is doing here, but with data points.
And one of the main jobs for unsupervised learning is something called clustering. The algorithm just looks at all the data and starts grouping things together based on how similar they are. Think about sorting a giant bag of mixed-up laundry. You'd start making piles of socks, t-shirts, and pants, all without needing a label to tell you what a sock is.
And this is incredibly powerful stuff. When your favorite streaming service says, hey, we think you'll like this show, how does it know? Well, it's an unsupervised algorithm that has put you in a cluster with millions of other people who watch the same kinds of things you do. It found a hidden pattern in our collective viewing habits.
So let's just put them side by side real quick. Supervised learning, with its labeled data, is all about predicting a specific outcome. It's like studying with that answer key. Unsupervised learning, on the other hand, is about discovering patterns in unlabeled data. It's more like being an explorer in a new city.
Okay, time for our third and final style. And this one is a whole different beast. It's called reinforcement learning. We're not even dealing with a static data set anymore. This is all about learning by doing. Here's the setup. You have an agent, that's our AI, and you drop it into an environment, which could be a video game, a simulation, or even the real world. The agent tries to do things. It takes actions, and for each action, it gets feedback, either a reward for doing something good or a penalty for doing something bad. Its entire goal is to figure out a strategy to get the most rewards possible over time. And it all works because of this constant feedback loop. The agent tries an action. The environment changes and gives back a reward. The agent learns from that reward and updates its strategy. Then it does it all over again, getting a tiny bit smarter with every single cycle. It's literally learning from experience.
This quote from Rich Sutton, who's a pioneer in this field, just nails it. With supervised learning, the feedback is like a teacher saying, "Nope, the correct answer was B." But with reinforcement learning, the feedback is more like, "Hey, that move you just made was pretty good. Here's a point." One instructs, the other just evaluates.
And the places this is being used are, well, they're mind-blowing. This is the technique that allowed an AI to beat the world's best player at the game of Go, a game that's more complex than chess. It's the foundational idea for training robots to walk and for teaching self-driving cars how to navigate a chaotic city street. All right, we've been through all three of the main learning styles. It's been a bit of a whirlwind, I know. So let's just zoom out for a second and put the whole picture together.
This little table is basically your perfect cheat sheet. You've got supervised learning, learning with a teacher using labeled data. You've got unsupervised learning, finding patterns all alone in unlabeled data. And you've got reinforcement learning, learning from experience through trial and error.
But, and this is probably the most important takeaway of all, in the real world, these three methods aren't kept in separate boxes. The most powerful AI systems out there today, like ChatGPT, use a combination of all three. They might start by learning language from the massive unlabeled text of the internet that's unsupervised, then they're fine-tuned with specific examples. That's supervised. And finally, they learn to be more helpful through human feedback, and that's a form of reinforcement learning. It's the blend that creates the magic. So that leaves us with one final, pretty wild thought to chew on. We've created machines that can learn in all the fundamental ways that we do. So the really big question isn't just what they can do, but what will they eventually be able to teach us? Thanks for watching.